Hello everybody, this lesson is on estimating square roots. So when you think of square roots, and actually you probably can't see some of this, let me move this down. So when you think of square roots, you are trying to find the number that multiplies by itself to get to this number. So for example, the square root of 9 I know is a perfect square. And if I need to approximate it or evaluate what that is, since it is a perfect square, I can place that square root of 9 on my number line. So since the square root of 9 is a perfect square, I would multiply 3 times 3 to get to 9. So square root of 9 is actually right here on our number line because I know that it evaluates exactly at 3. It's a perfect square. Square root of 36. 36 is also a perfect square, so if I take the square root of 36, I would be multiplying 6 times 6 to get that, so the square root of 36 is at 6, so I can place that on my number line. Square root of 25, also a perfect square, it would come out to be 5. But now the square root of 50, square root of 50 is not a perfect square. But if I were to approximate it, so what that means is to estimate what that value is, I would want to think about the perfect squares that are closest to it. So I know that 6 times 6 we get 36. If I square 7, so 7 times 7, that would be 49. Well, 50 is really close to 49, so I could approximate that 50, or the square root of 50 would maybe be about right here. It would be close to 7, because if I were to take the square root of 49, I would get 7. So the square root of 50 is going to be really close to 7. Square root of 100 is a perfect square. Think of what number times itself equals 100. So 10 times 10 equals 100. I would place that number here for square root of 100. And our last one, square root of 6. So we knew at the beginning we found the square root of 9 to be 3. Another small perfect square is the square root of 4. And that one actually comes out to be 2. So since 6 is between 4 and 9, I know when I take the square root of it, it needs to be between 2 and 3, because here was our square root of 4. And the square root of 6 is closer to the square root of 4 than it is to the square root of 9. I would probably put the square root of 6 about right there. So we're approximating that that's where that square root would be. So in today's lesson, we're going to really be looking at how to figure out what integer numbers a square root is between without using a calculator, and placing that on a number line. So for example, if I take the square root of 55, I don't have a calculator, I don't know what it is, but I know I can figure out roughly what it is by thinking about the perfect squares both above and below. And this is really where it's helpful if you don't know your perfect squares. So like 1 times 1 is 1. 2 times 2 is 4, 3 times 3 is 9, and so on. You could look up a chart that would have all of them listed, or you could do, actually multiply it out by hand to get the number that's closest. But you want to be able to identify where you would put the square root of 55 on a number line. So you want to think of the perfect square, the closest perfect square that's less than 55, and the closest perfect square that's greater than 55. So thinking about our perfect squares, I know 6 times 6 is 36. 4 times 4 is 49. Or not 4 times 4. 7 times 7 is 49. And then 8 times 8 is 64. Well, 55 falls between those two. So the perfect square less than 55 would be 49. And the square root of that number is 7. And the perfect square greater than 55 is 64, because I multiply 8 times 8 to get 64. So 8 would be my integer. So I know that the square root of 55 has to be between 7 and 8. So if we think of what number 55 is closer to, between 49. So 55 minus 49. Oops, so 15 minus 9, we have 6. It's 6 away from 49 if I subtract for 64. 64 minus 55. So 14 minus 5 is 9. It's 9 away from 64. So it's going to be a little closer to the square root of 7. And it's not quite halfway, so I would probably put it about right here on our number line for the square root of 55. So trying another example, square root of 78 this time. So thinking about the perfect squares closest to 78, both above and below. So the perfect square below 78, we already did 8 or 64. 64 was 8 times 8. If we try 9 times 9, that's 81. That's too high, so 8 is going to be the smallest at 64 for our perfect square, and that number was 8. Perfect square closest to 78 that's higher is 81, and the square root of that is 9. So now if we think of what's closest, if I do 78 minus 64, it's 14 away. So 14 away from 64. If I subtract 81 minus 78, it's only 3 away. So a good estimation for this one, square root of 78, would need to fall somewhere really close to the square root of 9. And if you're going to approximate it as a decimal, I would probably say about 8.7, maybe 8.8. And you can check it with a calculator, but the purpose of this lesson is to figure out approximately what it would be without using a calculator. So if you're close, that's okay. The whole purpose is to try it without actually needing that calculator. Okay, one last example. If I want to estimate the square root of 45, and estimate and approximate are similar terms. So thinking of the perfect square above and below 45. So perfect square above we've used already. Square root of 49 is really close to 45. And then, so this was 7 times 7. So then 6 times 6 would be the closest perfect square below that number. And square root of 45 is closer to 49. So our answer is going to be closer to what the square root of this is. So square root of 36 is 6, square root of 49 is 7, and 45 is only 4 away from 49, so our decimal value is going to be much closer to 7. So this would be another one where I would approximate this to maybe be about 6.8 or 6.7 because it's close. And I'm just going to check this time on a calculator. If I type in 45 and I take the square root of it, this one actually comes out exactly with my calculator to be 6.708. So I was off by a little bit, but I was close to what it would be. I knew it was going to be larger than halfway, but it's going to be closer to 7. Okay, and the last example I have with this, square root of 68. It's between the square root of 64, which is 8 times 8, and the square root of 81, which is 9 times 9. So we're comparing between 8 and 9. And 68 is really close to 64. So my decimal is going to be much closer to 8 than it will be to 9. So I would probably guess maybe 8.2 is an approximate answer for that one. And I'm just going to check my calculator. 68, take the square root of it. 8.24, so maybe round 8.25 if you were rounding up to hundredths place. But we were close with that one. So your assignment for this lesson is on page 352, numbers 1 through 6. all of them, and then 11 through 17 odd, and this is just a listing of those questions that you will use for this lesson. So you can pause this, complete those, and make sure you turn in these problems at the end of the unit.